Example 6.7. Harold owns a construction company that subcontracts to international power equipment corporations. For the last 4 years, he has leased crane and lifting equipment for $32,000 annually. He now wishes to purchase similar equipment. Use an MARR of 12% per year to determine if any of the options detailed in Table 6.6, this one, are financially justified. Okay, so first of all, we have a minimum attractive rate of return of 12% per year. This is going to be our target, so we want to get at least 12%. Okay, but then we're going to compare these 4 alternatives over here and see if there's one that gives us a better rate of return. First of all, well, this problem requires a series of steps, and we will be going over it step by step in order to find the best alternative. Okay, so in this slide, you can see that there's 5 steps. Well, the 5th one is to repeat everything over and over again until you run out of alternatives. Okay, so step number 1 will be to order the alternatives by increasing initial investment. Okay, so we previously had talked about how the P, or the initial investment, influences the rate of return analysis. So we must order them by P. However, over here it says that whenever you have revenue alternatives, we must also take into consideration do nothing. So I'm going to go one slide before, and here it's where they describe this rule, saying that if you only have cost alternatives, meaning that let's say all of your A's are going to be negative, you only have an annual operating cost, then you just go ahead and compare alternatives 1, 2, 3, and 4 against each other. However, if you have a positive A, or let's say that you have an annual revenue listed, then you must also compare do nothing, okay, and you're going to compare that against the other alternatives. Okay, so let's start with step number 1. But first of all, let's see what we have here. So we have our first cost, and this applies to all of them. So our first cost would be the P. We have the annual cost, so this will be a negative A. Then we have the annual revenue. Okay, this annual as well, but it's revenue, so must be plus A. And then we have the life. But here it says revenue. Okay, so remember that in the rules it says that whenever we have revenue alternatives, then we must compare do nothing first. Okay, so now let's start with step number 1, which is order alternatives by increasing initial investment. Or in other words, by increasing P. Okay, so here it says to compare do nothing first, and the reason we compare do nothing first is because since we're not doing anything, then our P will be 0. Okay, so over here I will list do nothing first. It has a first cost of 0. It has an annual cost, so this is everything that's additional. So since we're not doing anything, the annual cost will also be 0, the annual revenue will be 0. And I'll talk about the life in years right now. So for the do nothing, we're not going to put anything yet. Then Which one's the next one? The next one, by increasing P, would be alternative 4. So for alternative 4, we have minus 20,000. Then we have minus 21,000. I'm just copying the values from here. 29,000. And then we have 4 years. Then the next one is alternative 2. This one has minus 50,000, minus 26, okay, then plus 43, and also has a life of 4 years. Then the next one would be alternative 1. This is minus 80,000, minus 28,000, 61,000, and also 5. And then the remaining alternative, which is alternative 3, minus 145,000. This is the most expensive one. Minus 16, positive 51, and this one has a life of 8 years. Okay, so I didn't put down the years for the do nothing yet because I wanted to see against which alternative is one it was going to compete with. Okay, so this is a competition, but they're going to be competing in pairs. Okay, and remember that since chapter 6 is based on present worth, okay, then the lives must be equal. Okay, so over here you will have different lives, but you won't worry about that until you evaluate alternative number 3. So for now, since, let me write down step number 2. Step number 2 is to compare the first 2 alternatives. Put else. In this case would be do nothing against alternative 4. Okay, and we're gonna determine the incremental cash flow. And this is from the slide. So then again, we're comparing do nothing against alternative 4, and since do nothing, it's what we have right now. So let's just use the same life of the alternative that we are comparing it to in order to avoid any confusion, okay, and also to make the problem easier. So let's compare the first 2 alternatives. So we're going to be filling out our incremental cash flow table. I already have the template here. Okay, so also remember that we must, for alternative A and alternative B, it's also by increasing investment. So we have here that the do nothing is the one with the lowest investment, so that would be alternative A, and then alternative B is the one with the highest investment of the 2, so this would be alternative 4. So now let's start filling it out. Here we don't have a salvage value, so we only have the first cost and positive and negative A. So also here for your reference, I'm gonna write down that this is P, this would be negative A, and this would be positive A. And this is the life in N that you will be using. But at the end, it will change because we have different lives. But for now, we have equal lives. So we may use the short version of our table. Okay, so remember that whenever you have equal lives, you can just say that this is our year 0. And then from years 1 through 4, we're going to have the same cash flows. Okay, so I'm just going to put a reference here that this is equal lives. And you may go back to the video for example 6-4, okay, or 6.4. Okay, so now we have alternative A. We copy the cash flows. So first cost is 0. Okay, and then also from years 1 through 4, we're going to have a net A of 0. And then for alternative B, we will have the minus 20,000. And we will have these two A's combined because they will occur yearly. So you will have minus 21,000 plus 29,000. Okay. And then we get the incremental cash flow. Remember, is alternative B minus alternative A cash flows. So here we have minus 20,000 minus 0. And then here we would have minus 21 plus 29, which is going to give us positive 8,000. These two amounts that we have here are the ones that we're going to be using in the next step. Okay, so we're going to be using this column, the incremental cash flow column, in our next equation. So if we have minus $20,000 occurring in year 0, this would be equivalent to our P. And if this happens from years 1 through 4 and it's the same amount, it's a uniform amount, then this will be A. Okay, so now let's go back to the steps. So we already did step number 2. So now step number 3 is where we're going to find, or we're going to determine the delta I. So we already got the delta cash flows. And now we want to get the delta I, which is our interest rate. Okay, so we're using a present worth based relation of the table that we just filled out. So that's why we're going to use these two amounts in setting up our present worth equation. So let me write down step number 3. Okay, determine delta I star, that's our unknown, using present worth relation. Okay. So in this case, our equation, we will be converting this to P. Okay, so basically we will have, well, minus 20,000, it's already in P, so you just write it down as is. And then the 8K is the one that we're going to convert to P given A. So it'll be plus 8,000, find P given A, delta I star, and then it's for how many years? For 4 years. After we have the equation already set up, and note that here we don't have a salvage value. If we had a salvage value, then you would have, if you go back to example 6.4, you would have year 4 on its own, and then you would have a cash flow. So you would have to add it here to the equation, okay, with find P given F. Okay, but since we don't have any, we just go with the P and the A. Okay, so now within the same step number 3, we must now interpolate. Okay, so go back to the previous video for the formulas and the explanation. Okay, and here with the interpolation, we will be doing our trial and error. Okay, because we don't know. And also in your notes, it is specified. I'll look for it. Okay, here, that we must use the trial and error method. So we are going to be doing this by hand. Okay, so now let me write down here as a note, this is trial and error. Okay, so for the trial and error, you're going to let delta I star be equal to any percentage that you want. So here you have the choice. You may pick a 5, you may pick a 10. It doesn't really matter which one you choose. Okay, so in this case, just for convenience purposes, I'm gonna use 21%. But then again, you may use any value that you want in here. That's why it's trial and error. Okay, so you're going to input this into your equation. So now the equation is going to look like this. minus 20,000 plus 8,000, find P given A at 21% for 4 years. So this right here is the only thing that changes in your equation. Okay, so you're going to go to the table and you're going to solve this. Go to the factor table for 21%, find P given A for N4, and you will find the following value. It's going to be 324.37. Okay. So for the interpolation, if you remember, we need a positive and a negative point, one of each. So in this case, we found the positive. So by solving this, we got a positive result. But now our next step is to find the negative result that we're going to be graphing. So just a heads up here, if you find a positive number, then on your next trial and error, you must increase the percentage. Okay, so the higher you go, it's going to become lower until you get the negative. Okay, so you can increase it by whatever amount you want. If you want to go to 25%, if you want to go to 30%, that's perfectly fine. In this case, I'm just going to increase it by 1. So I'm going to do let delta I star equals 22%. Okay, and I'm just increasing it by 1 because this number is not that high. If you had thousands here, then it would be feasible to increase it by a larger percentage. But I'm just going to go with 1% up. So it's going to be minus 20,000 plus 8,000, find P given A at 22% for 4 years. Here's my 22%. And if you solve this, it's going to give you minus 51.2. Okay, so I got the result that I wanted. I got my negative result. So now I am ready for the interpolation. Okay, so I will be graphing this because it's easier to see whenever you graph it. So you would have the one axis there, the y-axis, and then here's the other one. Okay, we said that this one would be your interest, and this one right here will be the money. Okay, so this is R0. Okay, I'm not putting the negative y because we don't need it. So this number right here, okay, would be the 324.37. Okay, and this is money. Okay, because whenever you solve this equation, it's going to give you money. So over here, just an estimated that, let's say that it's somewhere around here, $324.37, and this one corresponds to 21%. Remember that this is a percentage, so let's say that the 21% is somewhere around there. Then, well, let me put the point. There's a point. And then the next one, it's minus 51.2 in dollars. So let's say it's there. Minus $51.2. And this one corresponds to 22%. So if I graph it, it's going to be somewhere around there. Okay, so we had said that for making like a standard for the class, the positive point will be x0, y0, and then the negative, it's going to be x1, y1. Okay, so if we plug in the values here, okay, x0 or x0 would be 324.37, and y0 would be the 21%. And same here, I'm going to plug them in. So this would be minus 51.2, 22%. Okay. The point that we must find is between these 2 points, and it should be where it intersects the y-axis. Okay, so here we will be finding our xy point. Okay, but we said that the x is 0. Okay, so you would have a 0, and the y would be your delta I star that you want to find with the interpolation formula. So now we are ready to interpolate these 2 points. Okay, and we use the formula, so it's going to be y equals to y naught plus y1 minus y naught times x minus x naught divided by x1 minus x naught. Okay. Once you have everything already set up here, then you just plug in the values into the formula. We said that y, it's actually your delta I star. Then y naught is 21 plus 22 minus 21 times 0 minus 324.37 is a point over minus 51.2 minus 324.37. Okay, so you may plug this into your calculator, and the answer will be 21.86%. So it intersects the y-axis in a point. It has to be between 21 and 22. So in this case, it would be 21.86. Okay, so this is the number that we are looking for. Then we have one last step, which is to compare the delta I star, this one that we just found, to the minimum attractive rate of return that's given to us in the problem. And here is the selection criteria. If the delta I star that you found is greater than or equal to the MARR given in the problem, we're going to eliminate alternative A and keep alternative B. If it's less than, then alternative A, it's going to survive, and we will be eliminating alternative B. So let's go back to the problem. For delta I star, okay, we got 21.86%, and given in the problem, just a friendly reminder, we have a minimum attractive rate of return of 12% per year. So we're going to compare this against the minimum attractive rate of return of 12%. Okay, so in this case, our answer, it's going to be greater. So therefore, we eliminate do nothing. Okay, because do nothing in this case would be our alternative A, and alternative 4 is the survivor. Okay. So up to this point, we have eliminated alternative do nothing. Okay, but we still have 4 more alternatives. So our next step would be to repeat everything we just did, but we're going to compare alternative 4, which is a survivor, to the next alternative. So for step number 5 would be repeat Okay, so now we're going to compare the survivor with the next alternative, which in this case it's going to be alternative 4 against alternative 2.